Today we'll be looking at some problems based on genetic algorithms. So just I want to discuss a few problems important from the point of view of your exams. So first of all, so we'll take up this question, that is maximizing f of x is equal to x square. Range for x is given. So this range will be given. Accordingly, you have to coin x. I mean, you have to encode x basically. So encoding will be based on the range. So here it is given 0 to 31. So that is why we are assuming that x is encoded using 5 bits. Okay. So accordingly, so if it changes, so if it is 0 to 63, then you go for appropriate bits. So how many bits this will require? 6 bits, right? 2 raised to 6. Fine. So accordingly, this will change. Next thing is we are trying to optimize the function. In this case, you are going to maximize f of x is equal to x square. So x square is the function that you need to represent, that you need to calculate. So that is why the fitness function, this will be the fitness function itself in this case. Okay, it could be f of x equal to x or some other function in x. Okay, so accordingly you have to compute the fitness at each generation. So what else will be mentioned is what is the kind of operators you have to go for. So it's given only crossover. So crossover, if nothing is mentioned about the type of crossover, you go for single point crossover. Okay, the type is mentioned explicitly, then you have to use that type. So whatever are the available types that we have, single point, multi-point, 2-point, and uniform crossover, if accordingly whatever type is mentioned, you have to go for that type of crossover. Okay, so there is no mutation which is mentioned, so no mutation operator has to be applied by solving the problem. If it is mentioned that mutate the 4th bit or 5th bit, it is mentioned, you may mutate it accordingly. Okay, if nothing is mentioned, but still it is mentioned that use mutation or mutate 1 bit randomly for each of the strings, then accordingly you have to solve the problem. Okay, so in that case different students will get different answers. Okay, it is not necessary that everyone will have
So, ma'am,
mutate the
we,
same bit.
we can use, in that case, we can use any mutation. Mutation type also we can use any.
So if it is not mentioned, then you go for flip mutation, point mutation. Yeah. Okay, if it is mentioned, again mutation type. I'll write it here for your reference. So if it is not mentioned, go for point mutation. Okay. Otherwise, if it is desired, it will be, you will be asked to go for a specific type. So maybe you are asked to do replace mutation. So if replace mutation is asked, then you select 2 points. Okay, and then just interchange these two. Okay, so accordingly, whatever is the type, go through the slides and see what is the mutation. So you should know the definition of each mutation which is mentioned. So whatever we have discussed, only those mutations will be there. Okay, you will not be asked anything else. If something else is asked, so if something custom mutation is asked, it will be mentioned. Okay, you have to mutate it in this fashion. Okay, so suppose I want to give some way of my own function for mutation. So I'll mention do the mutation in this fashion with example. So then accordingly you have to use that for the problem and then mutate. Okay. So next is, okay, this is about the operators. Okay. Selection, as far as the selection is concerned, again, selection is also important. Nothing is mentioned. Default is always roulette wheel selection. Always it is default is always roulette wheel selection. Okay, the traditional technique for selection is roulette wheel selection. So whatever problems, if it is not mentioned, you go for roulette wheel selection. Okay. And also pay attention here, whatever is mentioned here, how many generations you are required to show. It could be 1 or 2 generations, because you're doing it by hand. It will be 1 or at the max 2 generations, depending on the marks allotted to that problem. Okay. So and these are the basics that you need to follow. Okay. So since they have mentioned 2 generations, so this will go on for 2 generations, but just let us understand how we do it. Okay. So the population is given to you. The initial population is given to you in this case. So it is 13, 24, 8, and 19. These are the numbers which are there, X values. Okay. So you have to encode it. You are encoding it. Okay. And so, of course, again, encoding schemes are also many. So you, by default, you are going to use bit mutation, bit encoding, binary encoding, right? Otherwise, it will be mentioned. Okay. So most of the problems, whatever which are asked for problem solving on genetic algorithms, you will have the so it will not be mentioned mostly. So you have to go for the encoding scheme, that is binary encoding. You have to go for single point mutation. Crossover is single point crossover, and roulette wheel selection is the default selection scheme. So these you have to follow de facto. Okay. If still you feel that, okay, I do not want to do it in this fashion, you have to mention your assumption. So you're bored, you don't want to do it in that way. It is, I mean, and nothing is mentioned in the problem. So it is up to you. But whatever you're doing inside, that has to be correct. So if nothing is mentioned, no constraints are mentioned, you are free to use anything, but you have to mention what you're using. All your assumptions have to be clearly stated while solving the problem. Okay. So now what we do is, since we are using binary encoding, we are encoding it in the
Ma'am,
form of zeros and ones. Yes.
so also only in case of mutation, if no mention of mutation is there, so we just don't have to use mutation. Otherwise, all the rest we have to use like
इसमें लिखा है ना,
selection and
use only crossover लिखा है ना. That means you do not have to use mutation.
oh,
है ना? So it will be mentioned, like if you have to use only mutation मैंने लिख दिया तो आप crossover नहीं करोगे, सिर्फ mutation करोगे ना. Possible ना? Yes, Shagun?
yes, ma'am.
Yeah. So whatever is mentioned, you try to understand, get a clear understanding of the problem, and then start solving. It will be easy. Okay. So now what you're doing is initial population, just encode it. Okay. Compute the fitness. It is x square is the fitness function. Then what you need to do is you need to find this fi divided by summation f. Okay. So this actually is giving you how much on, what is the proportion on the wheel, basically. What is the proportion on the wheel? That is this figure. So fitness divided by summation f, right? So that is the proportion on the wheel. Next is the expected count. So this is the formula which I discussed about expected count. Okay. So you have to use this formula. Fi, not clear here. Fi, that is the individual fitness of that chromosome. So fitness of this ith chromosome divided by f bar. F bar is the average fitness. So you compute the average fitness. So you're computing the average fitness. So from summation, you have summation f. So average fitness will be the total fitness divided by the number of chromosomes that are there in that population. So whatever is the population size, so divided by population size. So instead of 4, if it is 8, then it will change. Okay, so don't always divide by 4. Use your logic. Okay, so look at the number of chromosomes. If there are 8 chromosomes instead of 4 or 6 chromosomes, then divided by the population size always. Okay, average. This is a mistake which students make. So if the population size is changed, students still divide by 4 because they have just marked up this table. So ऐसे नहीं करना है. You look at the situation, look at the number of individuals that are there, and then you do it. Okay, and then expected count. So this is, you will get some decimal number. So what you need to do here is, using this expected count, this is very important, expected count, because using this you are going to actually compute the actual count. So using this only, you are going to find the actual count. What is the meaning of this? How many copies of this chromosome will be used for generating, or for generating the next population, for generating the population in the next generation. Okay, so 0.58, so 0.5 के ऊपर जो भी रहेगा, you have to round it up. Okay, so 0.5, you take one copy of this is 1.97, so take two copies. This is 0.22, so it is 0, so this goes off. This chromosome is weak, so this goes, the 8th one. Okay, because it is close to 0. 1.23, so close to 1, so take it as 1. Okay, so 1201. So you will see that this particular individual, that is 24, is having the highest fitness here. So it is actually getting two copies, so it is getting it is being favored actually, right? So two copies are selected for the next for the operations to be performed, that is crossover and mutation will be performed. In this case only crossover, but the next operation. So this is selection is done. Now what you're doing is you're selecting one copy of the first string, second two copies of the second, third string dies off, fourth string one copy. Okay, so these are the four selection. This is the selection phase. So this concludes the selection phase. Okay, next what you do is, so after selection, this is you're going to use for crossover, right? So you're going to use this population for crossover. So using the first two, okay, so how are you placing it? So first string, one copy, second string, there were two copies, you place it in that order only. Okay, now uh, two at a time you're going to combine using a 1 point crossover. Now it is not mentioned what is a crossover point and all that, and you're assuming that all the strings are undergoing crossover, because it is mentioned that the crossover is with 100% probability. That means all pairs of strings have to undergo crossover. That is what you're assuming. Okay, so you simply have to choose a crossover point. Crossover point is not given to you, so you choose any crossover point. So different people will get different strings here. So depending on the crossover point. Okay, so just do a crossover, and then what you will do, so for the first one you have selected the crossover point as 4, you can see, or crossover point or crossover site or cross point, the same thing. Okay, you have selected as 4, and here you have selected as 2. Okay, so then accordingly you will perform crossover, and this is the population that you get after performing crossover. So then what you need to do is you need to compute the fitness. There's only one operator which is used. Now compute the fitness of the strings, new strings that you have got, next population, the next generation's population. So these are the fitness values. So these are the strings, these are the fitness values x and f of x, right? And so now you will see here, in this case it has improved the fitness. Okay, so this is the population that you get here, this one, after one generation. Okay, so 27 is the highest fitness. So that is what is there. The sum is just printed, average is printed. That is not important, but the maximum fitness is important. So after the first generation, the maximum at the first generation, 0th generation, that was the initial population. The randomly generated string, whatever the population was given to you, that was, what was the highest one? It was 24. Now the highest one is 27. So now your maximum fitness has increased. Okay? That is what you need to write. That's it. So you need to write, after performing all this crossover mutation, whatever operations are given, this is what you're getting. Okay. So
What
everyone,
is
Ma'am,
that
only
second
thing
column
is,
seems
all
like?
calculations have to be shown. Okay. The tables have to be drawn. Yes.
मैम the second column mate selected randomly इसका मतलब क्या है?
So this again, what is being done is, when you are doing crossover, it is not necessary. So you will get a pool of of chromosomes. It is not necessary that you are going to do it in the same order. Okay, here it is done in the same order. ये वही है 1 2 3 4. So ये तो second के दो copies वाला ही है ना, same order में ही हुआ है. See, but it is not necessary. You might select 1 and 3, 1 and 3, 2 with 4. So that also you write what you are selecting. That also can be done. Okay, so depending on that also you can have different answers. So answer सबका अलग आना चाहिए, लेकिन कॉपी करोगे तो सबका सेम आएगा.
मैम वो
हाँ.
जो पॉपुलेशन है वहां पे भी फर्स्ट 2 के लिए फोर्थ पॉइंट पर क्रॉसओवर ये लिया सिलेक्शन पॉइंट, एंड लास्ट 2 के लिए सेकंड पॉइंट पर, तो वो हर एक के लिए डिफरेंट ले सकते हैं.
Yes, crossover site is always random. It is never while doing your GA. I hope you have done it that way. It is never one. Na? It is crossover point is randomly selected. If
हाँ,
you use
like
1 point
while
crossover,
solving,
it is not that fourth point only you will select or third point. It is random. No?
while solving, like we can also keep all the points same and solve.
You can do that. Yeah, you can do that. No issues. Whatever you're doing, that has to be written there. That's it.
Ma'am, at the end of the generation, the fitness might go down, no?
It might go down. It depends on what you're choosing. No?
Yeah, so I mean that's fine, right? We
That
don't have
is
to
fine.
choose in a way it increases.
No.
Okay.
But you should know how to apply that is what I'm saying. Now here nothing is given, everything is default. Now I say instead of roulette wheel, you use rank selection. What will be the changes that you need to make here?
We'll first be assigning the ranks based on fitness, and then we'll following this process.
Then again you will use roulette wheel selection only. So 1 2 3 4 fitness के हिसाब से rank दे दो, है ना? So in this case I'll just put a point here and say, so in this case ये है ना fitness values. So based on the fitness, what is the rank? I'll just use some other color. So rank is, this is 1, right? This is 2. Sorry, this is the lowest will have the lowest rank, right? The lowest fitness will have the least rank. So 1, 2, 3, and 4. Okay. So now what will happen? What is the fitness of this individual? It will change now. Correct? It will be 1 by 10. So since the population size is 4, it will be, it will change. The fitness will change. Okay, 1 by 10, 2 by 10, 3 by 10, 4 by 10. Okay. And then now you have to do the same procedure. Same procedure you have to do. Correct? You have to use roulette wheel selection only. Are you getting it?
Yes, ma'am.
Yeah. So please be careful about what operators, if anything is mentioned, you use it accordingly. Okay. So this is asked for 2 generations, so this continues. So you have understood the process. So if it is asked for 2 generations, after this also you don't have to stop. After this table again, select this for this population, the last population that you generated by after performing crossover, this one, right? You are going to move ahead and do the same process, repeat the same process for one more time. So again, you have the selection here. So this is selection, the expected count, actual count, and then you perform the crossover. Okay, and you get the fitness values. Okay, next problem. So in this problem, what is given is consider the population of a string with 10 bits each. The objective function is the number of ones in a given string. Okay, so you have to based on the number of ones, you are going to compute the object. That's the objective function, and then the fitness function is given. Fitness function then performs divide by 10 operation to normalize the objective function and show the computation of minimum of 2 generations. Again, this is given, that is okay, but assume that exactly 50% of the individuals undergo crossover and mutation rate as 5% with the population size of 4 individuals. Okay, so now nothing is given, the population is not given only. So here in this problem, the population also you have to assume. Only thing is given is that the population size is given. Okay, if that is also not given, that also you have to assume. But if population size is not given, minimum you can assume 4. Okay, if population, I'll just write a note here. Population size, if it is not given, assume it to be 4. Okay, that is minimum. Above that you can go, but minimum 4 you have to go. Okay, and then so let us solve this problem. So the same process you have to follow. Only thing is the initial population is not given, so you have to assume that. So let us try to do one generation of it. I'll just solve it by hand. Just a minute, I'm sharing my screen again. Yeah. So let us assume some population. Okay, what is given is the population, the length of that string is 10 bits, that is given. So that will be given if that is given. So assume strings of that length. You're assuming strings of that length. So 10 is given. 10-bit string is given, and population size is 4. Okay, so what you need to do is, this is the solution to problem 2 solution. Okay, so just assume the strings. So again, draw that kind of a table. So that table will come here. That string number, initial population, that kind of a table you make, population. Then the objective function, fitness function, and then expected count, actual count. So I'm just writing the expected count and the actual count. Okay, the chair on the wheel is not required because this expected count, this column actually gives you the actual count. So this is important for our calculation. So string number 1, 2, 3, 4, 4 strings randomly you generate. So any 4 strings we will take of size 10. Okay, so let's say this is one string. It could be any random strings that you have, unless and until it is given to you. Right? Okay. So these are the strings that we have. So objective function is the number of ones. So we'll write it 3. How many ones are there? You just count the number of ones and write it. 3. Then you have 6 ones. Then you have 1, 2, 3, 4, 5, 6 again. Right? And in this you have everything is ones except this 0. So it is 9. Okay. So the fitness function that we have here is given that you normalize it. You normalize this value by dividing by 10. That is the fitness function. So this is 0.3, right? So it is this objective function divided by 10. Okay, that is the fitness function, objective divided by 10. So 0.3, 0.6, 0.6 and 0.9. Okay, so this is the fitness function. So according to this, you compute the expected count. So how will you do it? You need to compute. What do you need to compute first? The summation, right? So below, you compute the summation of fitness. What is the summation of fitness?
2.4.
2.4.
2.4.
Correct. So 2.4 is the sum. Then what you do? You compute the
Average.
Average.
average, right? So average fitness, I'll write F bar. Okay. So F bar is 2.4 divided by 4. That is, what is it?
0.6.
Divided by 0.6. Yeah. So 0.6. Now using this average fitness, we can compute the expected count. That is F bar. I'll write this here. F bar divided by summation. Sorry, average. Sorry. Fi divided by F bar. Right. Fi. This is Fi. Right. This is Fi. Fi divided by F bar is the expected count. And then, so you will get this as
0.5.
0.5. What about next?
1.5.
1 point. So now the thing is, here now you have exactly 0.5. So if it is above 0.5, see, because here there's a contention now, which one to choose. See, usually when you use in the implementation roulette wheel, it is randomly selected. If you remember the curve is like distorted. I mean, what happens is it is randomly selected. It is not necessary that even though it is having some high fitness, that only will be selected. It is possible that only one copy of this is selected and another copy of this is selected. It is possible when you are implementing it practically. Why? Because it is random number generation. No? That is what you do. But here this is a simple formula that is used when you are computing it by hand. Okay, so it could go either ways. There is a point of contention here. So what we will do here is, since this is 1.5, okay, you can one student can write this as 1 1 1 1. Some other student can write this as 0 1 1 1 0 1 1 and 2. Okay, since it is exactly points. Okay, so let me choose. So it is correct. Both are correct. Okay, so I'm choosing it as 0 1 1 2. I'm just assuming that is the lowest fitness, so it is dying off. Okay, so 0 1 1 2, and then what you do is the next generation. Are you going to apply some operations on this? This is the count. So this is the uh, these are the strings which are chosen for crossover and mutation, right? So to produce the new strings. So now in the second table, what you will do, using these strings, you will apply the two operations which are given. So mutation and crossover. Mutation, if you're talking about mutation, first of all, before mutation, you will apply crossover. What is mentioned in the question? That your exactly 50% of the strings undergo crossover. 50% of the strings undergo crossover. And 5% is the mutation rate. What is the meaning of this? 50% of the strings is crossover, that is fine. That means out of the 4 strings that we have, so whatever 1 1 1, these strings, that is second, third and fourth ke 2 copies, these strings. Out of these 4 strings, you are going to apply crossover to only 2 strings, 1 pair of strings, that is. So any one pair you select, so that is again randomly selected. So out of these copies that we have, so we need to write the other table again. If you remember the second table again here. So suppose I'm writing it again. So I have 1 2 3 4, string number 1 2 3 4. So 1 is this string, right? Let me keep it. Yeah. So 1 is 1 0 0 0 Okay. Second one is 0 1 1 0 1 0 1 0 1 1. Okay, and then 2 copies of this I've chosen. Okay, so now yeah, so from on these strings, out of these strings, it is up to me. I can choose this with this, or this with this, or this with this, and these two will not undergo crossover. Okay, so if I am going for these two strings, let me see which two strings will undergo crossover. Any two strings. So let me go for, say, the first and the last string. Let me say I'm choosing these two strings to undergo crossover. Okay, so what I need to do, I need to choose the crossover point. Okay, now if I'm going for crossover point, since it is single point crossover, I will, it's not given what type of crossover is not given, right? So I am choose any random point. So what am I going to do? Beyond that point, whatever is there, I'm going to interchange. Let me choose this point. I'm just choosing it because it is easy to visualize. Okay, so the strings that I'm going to get here are after crossover. Okay, are 1 0 1 1 0 1 1, and this side will come. Okay, and the remaining two will remain the same. Remaining two will be unchanged. So this will go as it is, this will go as it is, right? So this is after crossover. Now what do you need to do? Again,
Mutation.
you need to perform mutation now. So with these strings, you perform mutation. So what is given is mutation rate is 5%. That means what? 5% means mutation is per individual. Mutation is not across individuals. It is not across the population. Mutation is per individual, right? So for a given string, so for example, for this string, you need to perform mutation. 5% mutation rate means out of these 10 bits, 5% of the bits will be mutated. What is 5% of 10?
0.5.
0.5. Okay, so let us assume it is 1 or 0 bits will be muted. So let you write a value, assuming 1 bit will be mutated, since the mutation rate is 5%. You write your assumption there. Okay, and then apply mutation.
Ma'am, like in this case, we have to take one only, na? Because if we take zero, then it goes to like 100% only crossover question.
Yes, yes, yes. That is why you should go for 1. Okay, so any one bit you randomly select. Again, suppose I'm choosing this bit. Okay, and okay, so apply mutation, and then you will get the new strings. Okay, and are you going to do it for only these two strings? No, mutation is per string. For all the strings you are applying the mutation. Okay, but within the string it is 5%. Understand this, the difference. Crossover is for the population, mutation is per string. Are you getting this? I can also mention that assume apply mutation to 1 bit, to any 1 bit of the population, or of the population. That will be make it very easy. But when I say 5%, then you will get confused, right? Whether you have to apply, look at the entire population or no. So keep this in mind clearly, that crossover is always across the population, because you're considering two strings at a time, and 50% crossover rate means 50% of the strings are undergoing crossover. Mutation means it is always per individual, per chromosome. Okay, so don't 5% मतलब वो पूरा देख के फिर कुछ mutate करोगे तो वो wrong है. So you do it properly. Okay, and then whatever is the value you are getting, that is the fitness. That's it. So whatever chromosome you are getting, again you compute the fitness, again you compute the fitness, and see which is the highest, and you just write that. Okay, so this is how you solve I'll give you two more problems which are there for solving. Okay, with the solution I will give it to you. Okay, just go through them. Okay, they are different. One is on a knapsack problem. So knapsack problem, uh, it's slightly different in the sense that, you know, 0 1 knapsack problem. Some of you, किसी ने तो implement किया था, I don't remember, recollect.
Ma'am,
But
so
0 1.
after mutation,
Hmm.
what will be how will we show the output? Like final answer, how we have to show it?
So after mutation ना, so you say ना, ये mutation point लिखो, जैसे crossover point लिखा था ना टेबल में, तो यहाँ पे see, here you write mutation point is string के लिए, right? So you will write now per string you are going to write. So this is 5, this is 4, this is 3, this is 2. Accordingly, you will get new strings here. Correct? You will get new
Yes,
strings
ma'am.
here. And then these strings you have got, whatever this set of strings you have got, इसका fitness निकालो. इसका fitness क्या है? 1 2 3 4 5 6 by 10.6 है ना? हर एक का निकालो. And so out of these, whichever is the highest, you say this is the highest fitness after performing one generation of the genetic algorithm. That's it. And this is the string and this
Okay.
is its fitness. That's it.
मैम अगर एक भी स्ट्रिंग का म्यूटेट किया तो सबको म्यूटेट करना कंपलसरी है?
नहीं जरूरी है, मैं वही बोल रही हूँ. It is 0.5 ना,
तो
0.05 ना.
उसमें से अगर 2 स्ट्रिंग का किया 2 का नहीं किया तो
चलेगा. You say ना, since it is 1, either one of the bits will be mutated. Sorry, since it is 0.5, 1 or 0 will be mutated. Write it. Write your assumption. Whatever you're written now, whatever you're doing now, just write your assumption. That's it. Yeah. Okay. So one is on knapsack problem. Two solved examples I'm giving. One is knapsack problem, 0 1 knapsack. Okay, just go through that again. Similar population is given to you, and then you have to apply the different selection crossover mutation. Same process you need to follow. Okay, and one will be one scenario based problem. It is simple only. Say same process you have to follow. Only thing is some kind of scenario is given to you, and you have to get the function. Just go through it. Just go through them. If you have any doubts, you can mail me or you can ask me on WhatsApp. That's it. Okay. So this is about problem solving as far as GA is concerned. This is the only kind of problem solving that is involved. Other kind of problems which could be asked on GAs would involve like some population is given to you directly, like something like this. Okay. Some kuch X set of strings are given to you, 1 2 3 4, or only two strings are given to you. Something like that. And then you are asked, what is, if I do 1 point crossover, what is the result? Okay, at using 5 as a crossover point, using 4 as a cross. If I do 2 point crossover by using these two cross points, 3 and 5, so I'll write the cross points 1 2 3 4 5 6 7 8. These are my cross points. Okay, so what is the meaning of 1 as a cross point for a string of size 8? 1 means after the first one. Okay, so for a string of size 8, how many cross points can you have? You can have, if the length is
7.
n, if the length of the string is n, then the number of cross points is n minus 1, that you can have. Okay, so I say after 3 and 5, I use 2 point crossover, and tell me using cross points as 3 and 5, what is the answer? Okay, use replace mutation for string. There are two strings, x1 and x2. Use replace mutation here and use for x2 and tell me what is the answer. These are simple straightforward questions which can be asked. Okay, this is on crossover mutation. Similarly, selection. Yes.
I mean, 2 point also, there is an option like which part you want to exchange, the center part or the first
No,
and the
no,
third
that is
part
in
of.
multi-point.
So here we change the center part only
Yes,
between the two
center
points.
point, center part, center part.
Okay.
Okay. So next is selection. Selection because any strategy will be given. Population is given, some selection strategy. Okay, tell me what is the result after selection? Which of the strings will be selected? Okay. Part of the problem. It is not the entire problem you have to solve. Part of the problem. Any one operator that could also be asked. So this is also simple, right? Okay. So this is all what is there with respect to problem solving. So I'm giving you these two problems, this as reference, and two more solved examples. Go through them. Okay. If any doubts you have, you can ask. Theory also I have uploaded the slides. Okay. So anything else?
I mean, selection, tournament selection, like how will we do on paper?
It will be mentioned how you're going to do, because it is probabilistic, no?
Yes.
So what you can do is it will be mentioned how you have to select, like in the sense that two at a time, ऐसे consider करो. Two at a time if you're doing, then you say randomly, you have to write it is random. Tournament selection is completely random. So you cannot show it on paper as such. If you have to show it on paper, it has to be again some random number that you're choosing. Assume that one won the competition. String 2 won the competition. You have to write it in that fashion. Okay. Let me see if I can get one more example on that. I will send that also to you.
Ma'am, tomorrow at what time do we have the IAC?
I see. I'm not sure whether you want me to keep it tomorrow. I didn't get. I mean, half of you are saying it is tomorrow. Half of you don't want it tomorrow. What is the thing now? I don't know. Is it clear?
No, ma'am. I mean, it's still half people want tomorrow, half people don't want tomorrow. We're not quite sure.
Can we have it on Saturday then or Monday?
Man, I
If you
think
need time to prepare, I don't know.
people are fine with Monday. Some people are not fine with the weekend.
Okay. Monday is fine for me. Is it okay for everyone else who were insisting on Friday, because it's your ISC na after all. So prepare and give na properly.
Yes.
It will not take much of your time, but you prepare properly. So in that, see when you prepare properly, so those two modules you will be prepared for the exam also, ESC also automatically, right?
Yes, ma'am. Ma'am, just send practice questions for GA, like